Let us discuss this boundary value problem. Solve y double dash plus 2y prime minus 3y is equal to 0. Y of 0 is equal to 0. Y prime of 1 is equal to 0. How can we solve this boundary value condition? We are given y double dash or y double prime plus 2y prime minus 3y is equal to 0. If I have y prime, it means I'm having dy over dx. If I have y double prime, I'm having d square y whole over dx square. It means this is the first order, this is second order. That is first derivative and second derivative. So this is y double prime, that is a prime like prime word. We can call it a prime, we can call it dash. So y dash is also known as what? Y prime, that is first derivative. Y double prime, d square 1 over dx square is also what? Second derivative. This is the boundary condition. That is, we have y of 0 is equal to 0, y prime of 1 is equal to 0. How can we now solve this boundary value problem? If you look into this equation, this homogeneous equation, it is the second order homogeneous. You can see that our phi of s is equal to 0. So this is the equation I'll be giving y double prime plus 2y prime minus 3y is equal to 0. So this is a standard form. This is a standard form of y double prime plus p of x y prime plus q of x y is equal to 0, where p of s is equal to 2 and q of s is equal to minus 3. You can see it from this homogeneous that p of s, that is the coefficient of y prime, is 2 and the coefficient of q of x is what? Minus 3. So how can we now solve this homogeneous? First thing is to what? We assume that, let's assume that y is summation ms. If you take the derivative of this, what are we going to have? It means if you differentiate, there's y prime. If you differentiate this, we are going to have m exponential mx. If you differentiate again, if you differentiate y prime, we are going to have what? Y double prime m square exponential ms. If I assume that y is exponential mx. If I want to differentiate this with respect to x, that is, I will differentiate when I'm having only exponential. I'm going to differentiate the power of exponential with respect to x. If I differentiate x, I'm going to have 1. 1 times m, I have m, then multiply by everything, exponential mx. If I want to differentiate m exponential ms again, I'm going to differentiate this power. I'm going to have m multiplied by everything here. I'm going to have m square exponential ms. I will now plug in this. It means whenever I say y double prime, I put m square exponential mx. Whenever I say y prime, I put m exponential ms. And whenever I see y, I put exponential ms. So let's plug in this into that equation. I'm going to have m square exponential mx plus 2 m exponential mx minus 3 y times exponential ms is equal to 0. I can factor the common term outside, or I can divide both sides by what? The common term, which is what? Exponential ms. So let's divide. Divide through. If I divide through by exponential ms, I'm going to have m exponential ms all over exponential ms. Then plus 2m exponential ms all over exponential ms. And then minus 3 exponential ms all over what? Exponential ms is equal to 0 all over exponential ms. This will cancel, this will cancel, this will cancel. I will be left with m square plus 2m minus 3 is equal to 0. This is a characteristic equation or auxiliary equation. So how can I solve this auxiliary equation or characteristic equation? It means for me to solve this, we talk about an auxiliary equation. That is, when we are solving this, we arrive to an equation where we call it quadratic equation, where we can apply our general formula, that is quadratic formula or factorization. So what am I going to do here is what? I can use factorization to solve this by finding two numbers. When I add it together, I'm going to have 2. The product of that two number, that's going to give me minus 3. So what is the two number? The two number are 1 and 3. It means if I have minus 1 and plus 3, if I have minus 1 plus 3, I'm going to have minus plus 2. If I multiply minus 1 plus 3, I'm going to have what? Minus 3. So these are the two numbers. So I'm going to have m squared, the variable of that value, which is what? M multiplied by any. I can take minus 1 first, or I take minus 3 first. That is minus m plus 2m minus 3m plus 3m, that is minus m plus 3m minus 3 is equal to 0. So what is my next step? My next step is what? To take the common term. M is common, so I'm going to m by grouping m minus 1. If I multiply this by this, I'm going to have this plus 3 m minus 1. If I multiply this one by this, I'm going to have this as well, is equal to 0. So m minus 1 equals 0. You can see that this is common here, this is common here. Since it repeats itself twice and it is common term, I'm going to take it at once. So I will now take m plus 3. I'm going to have m plus m minus 1 and then what? M plus 3 is equal to 0. Then I will now solve this. I'm going to have m minus 1 is equal to 0, or m plus 3 is equal to 0. So what am I going to have? I'm going to have m is equal to what? 1, or m is equal to what? Minus 3. What I do is what? I have to take my constant to the right hand side because 0. I have to take this one plus 3 to the what? To the right hand side. So my general solution for this, y of s, remember in case A, this is our what? Our first case. The rule of the first case is that if our m1 is not equal to m2, we have a general solution of A exponential mx plus B exponential ms. That is m1 then m2. Since this m1, since m is equal to 1 and m is equal to what? Minus 3, they are not equal because 1 is not equal to minus 3. This will be my general solution case. That is, this is my case for this general solution. So I will now plug in, whenever I see m, I plug in it here. This one will take m1, this one will take m2. I'm going to have y of s is equal to a exponential x plus b exponential minus 3x. M as 1 times this, I'm going to have x, minus 3 times this, I'm going to have minus 3x. So what am I going to do next? My next step is to make. What is my next step? My next step is to what? To consider the boundary condition. This is our boundary condition. So it means when y of 0 is equal to 0 and y prime of 1 is equal to 0, it means I want to look from the solution to this boundary. So at y of 0 is equal to 0. This inside this bracket means x, that is when x is 0, y of 0 is equal to 0. I will now plug in this into this general solution. So I'm going to have y of x, there's y of 0 is equal to a exponential 0 plus b exponential minus 3 0. So what am I going to have? I'm going to have y of 0 0. Y of 0 is what? 0 is equal to what? A plus b. So from here, a is equal to minus b. I can call this one as equation 1. So let me now consider the second boundary condition at y prime of 1 is equal to 0. It means since y of x here, our general solution is a exponential s plus b exponential minus 3x. It means I have to find the first derivative of this solution, y prime of. So I'm going to have y prime of this, y prime of x. It means I want to differentiate with respect to x. If I differentiate with respect to, I'm going to differentiate this only. You can see this is a what? This is a product. I'm going to take a multiply by, if I differentiate exponential x, I'm going to have what? Exponential x. I'm going to take plus, taking exponential. I will now differentiate a with respect to x, and a is what? Is not with respect to x, that is 0. Everything multiplied by 0, so I will be left with only this. Plus, I will take b. I will now differentiate exponential minus 3x. Remember, when I deal with exponential, as I've said earlier before, we are differentiating with the power of that exponential with respect to x. I'm going to have minus 3. Minus 3. So minus 3 multiplied by everything, I'm going to have minus 3 exponential minus 3x. Then, if I now plus, take the exponential minus 3x, differentiate b with respect to x. There's no x to be found in b, so it will be 0. Everything will be 0. So I'm going to have a exponential x minus 3b exponential minus 3x. You can see from here that I've found my y prime of x. So my y prime of 1, so that I can be able to use my 1, s is equal to 1, then s is equal to 1, y is equal to 0. That is y prime of 1 is equal to 0. I'm going to have y prime of 1 is equal to a exponential 1 minus 3b exponential minus 3, 1. So my y prime of 1 is equal to what? 0. Is equal to a exponential minus 3b exponential minus 3. So you can see that I can make this one as equation what? Equation 2. Because I have a exponential minus 3b exponential minus 3. So since equation 1 is a is equal to minus b, I can plug in or put in, whenever I see a, I put minus b in equation 2. So I'm going to have 0 is equal to a exponential minus 3 minus 3b exponential minus 3. So I will now substitute when a is minus b. So whenever I see a, I put minus b. A is equal to minus b exponential minus 3 minus 3b exponential minus 3. So I can factor the common terms. I have 0 is equal to what? Minus b is common, exponential minus 3 plus 3 exponential minus 3. If I multiply minus b by this, I'm going to have this. Minus times plus minus b times this, I'm going to have this. So what am I going to do? I want to get my b. The reason why we are giving this boundary condition is to what? To get the general solution and to find the real constants of alpha 1, alpha 2 in our previous lesson, and to find what our general solution, the constant, that is the constant of general solution, what is the value and the general solution of it. Is it trivial solution or non-trivial solution? So what am I going to have? So I can divide both sides by exponential minus 3 plus 3 exponential minus 3. So I'm going to have 0 minus b exponential minus 3 plus 3 exponential minus 3 all over exponential minus 3 plus 3 exponential minus 3, and this one exponential minus 3 plus 3 exponential minus 3. 0 divided by this, I'm going to have 0. B, you cancel this, I'm going to have minus b. So it means 0 is equal to minus b. So b give me what? 0. Since my b is 0, I can use equation 1 to find my what? To get my a. A is equal to what? Minus b. So my a will also be what? Minus 0, which give me a is equal to 0. You can see that a is equal to b is equal to 0. So it means what our a is also our b. And whenever we have a solution in form of this, we call it a trivial solution. It's a trivial solution. I said it in our previous lesson. And if my solution is not equal to 0 or is not identically 0, I'm going to have no trivial solution. So my y of x here, is, so my general solution of y of x, that's my general solution for this second order homogeneous, is a exponential x plus b exponential minus 3x. My a is equal to 0, my b is equal to 0. Plug it. So I'm going to have 0 exponential x plus 0 exponential minus 3x, which my y of x is equal to what? 0. So this is my general solution to this. So I'm going to find my real constant, that is my alpha 1, my beta 1, We want to test from the theorem. Remember this, in our previous lesson, I explained a determinant that if this determinant is equal to what? Is equal to 0. It means it's not our general solution. That is, our determinant is equal to what? 0 as well. So we are going to apply that determinant to find, is it the determinant give us 0? If the determinant give us 0, it means our general solution for this boundary value condition is the general solution for the what? The general solution of homogeneous and the determinants. And if it's not equal to 0, it means the general solution of this problem is y of s is equal to 0. So let's start. Now remember that our determinant is in form is this alpha 1 y1 of a, alpha 2 y1 of b, plus beta 1 y prime of a, plus beta 2 y prime of b, alpha 1 y2 of a, alpha 2 y2 of b, plus beta 1 y prime of 2 of a, and plus what? Beta 2 y prime of 2 of b. So for us to find this determinant, we are going to consider all this. So for us to use this determinant to get, is this determinant give us 0, to find another what solution, that is it only g of x, y of s is equal to 0 that give us the only solution of a trivial solution. So we have to test for this. If this one give us a trivial solution, it means the solution that give us trivial solution is y of s is equal to 0 and this. And this, if this one does not give us, it means the only solution is y of s is equal to 0. We are going to find the real constant of this alpha and beta. If you look our boundary condition of this boundary value problem, we have of this value problem when we have y double prime plus 2y prime minus 3y is equal to 0. We have a condition, boundary value condition of y of 0 is equal to 0, then y prime of 1 is equal to 0. So for us to get our real constant for alpha and beta, remember that I said that when you have alpha 1 y1 of a plus beta 1 y prime 1 of a, and then alpha 2 y1 of b, then plus beta 2 y prime of b, y1 prime of 2. It means we are going to get our alpha 1 from our boundary condition. It means the coefficient of y here is alpha. This is alpha 1 y of a. So here we can see that our alpha 1 is equal to what? Our alpha 1 here is equal to a. Our alpha 1 here is equal to 1. The coefficient of y here is what? 1. That is y multiplied by y1, I'm going to have 1. Then what's our a here? Our a is this, which is 0. So it means our a is 0. What's our beta 1? If you look on beta 1, we don't have beta 1. Our beta 1 is 0. Our a is 0. Our beta 2 is 1. And then our b is what? Our b is 1. So it means this is a what? This y prime of 1 is equal to 0. It stands for beta 2y prime, beta 2y, beta 2y prime of what? Of b. That's our coefficient of what? Beta 2 is y prime, which is what? The coefficient of that y prime is 1. Why our b is what? 1. The reason we don't our beta 1 is equal to 0 is that it follows that for our beta 1 we're going to have alpha 2 y1 of b. For our beta 1 we're going to have beta 1 y prime of 1 of a. You can see from here that we don't have beta 1. That is, it must have 0 of this. We don't have beta 1, which our a is what? A is 0. So that's why we don't have beta 1. So it means we are now going to find what this one means. Then we'll now substitute all this into this. Since we are getting our alpha 1 as 1, our beta 1 is 0, our a is 0, our beta 2 is 2, and b is 1. So we are going to find alpha y, y2 of a, alpha 2 y2. So how are we going to get alpha 1 y2 and beta 1 y2? So we get it from the general solution of this when we have y of s is equal to 0. So it means the coefficient of a here is exponential x, which will take alpha 2 y2 of a respect to what a. Then our beta 1 y prime of 2 will take exponential minus 3x. So let us now find the real constant of this. When we find the real constant, then we plug it here. And also we have alpha 1, we don't have beta 2. Alpha 2, we don't have it. Alpha 2 is also 0. So our alpha. So here we have y of x. Our general solution is y of x is what? A exponential s plus b exponential minus 3x. So our y of x of a, it will now be y of a will now be exponential x. That is when our a, then y of b will now be what? We have exponential minus 3x. So we are going to get all these things from here. So it means our alpha 1 y2 of a. Remember that our alpha 1 here is 1 already. So our y2 of a, so we are talking about this. This is y2 of a, then this is y2 of what? Y2 of b. So since our a is what? A is 0. I will plug in. So our y2 of a, will be what? Since our a is 0, I will plug in. Whenever I see 0, I put our a will now represent our x. That is our s is what? A. So I'm going to have e is equal to 0, which one is 1. So it means my alpha 2 y2 of a is what? 1. So I can write it here. That is my y2 of a is equal to what? 1. So let me now find alpha 2 y2 of b. So this is what? This is also what? Alpha 2. This is also what? This is alpha 2. This is what? Y2 of b. This is also y2 of b. What is our b? Our b is what? Our b is 1. It means since my y2 of b, my b is 1. It means whenever I see, whenever this one will not be my b. So it means whenever, because my x will replace b, because we are not giving x in that function, we are giving a and b. So x will take a, x will take b. So I'm going to test according to what? To what it has to do. So it means I'm going to have, when my b is what? 1, that is exponential s, I'm going to have e, this is 1, this is 0, e minus 3, 1. I'm going to have exponential minus 3. I'm going to have exponential minus 3. That is e minus 3. So my y2 of b is exponential minus 3. So I'm done with this. And in the other, beta 1 is what? 1. So let us now find beta. This y2 of, this is y2. So let me now find y2 of a prime. That is y2 of a prime, which we have it here, y2 of a prime. So what am I going to have? If I differentiate this one, y2 of a prime, I'm going to have what? Our a is what? ea. So e, if I differentiate, I'm going to have what? ea. That is exponential x. So I'm going to have exponential x because I'm using exponential x. So I'm going to be using exponential x. That's exponential x. Here I'm going to have y prime of 2 of a. So that's what? Exponential x. So what am I going to have next? So I'm going to differentiate this y prime of 2 of b. That's exponential s. I'm using exponential x. So I'm going to have minus 3 exponential minus 3x. If I differentiate this, I'm going to have minus 3. That's what? Minus 3 exponential minus 3x. That's what? Our y prime of what? That is our y prime of 2 of a. Y prime of 2 of b is equal to what? Minus 3 exponential minus 3x. So we now plug in all these things according to what we are given. So alpha 1 What's our alpha 1? Alpha 1 is 1. Y1 of A. What's our Y1 of A? Our Y1 of A, that is, it means Y1 of A is what? We are going to find our Y1, that is our A. So our A is what? 0. So we are going to beta 1. What is our beta 1? Beta 1 is what? 0. Our beta 1 is what? 0. Y prime of 1 of A. It means Y prime of 1 of A. What do we have here? Our A is what? Our A is what? 0 as well. We are going to do alpha 2. What's our alpha 2? Alpha 2. If I put alpha 2 here, 0. Then Y1 of B. What's my Y1 of B? So my B here is 1. Then 0 times 1, 0 plus beta 2, Y prime of B. It means what is my beta 2? My beta 2 is what? My beta 2 is what? My beta 2 is what? 1. Then Y prime of B. That's what is my B? My B is also 1. So it means I'm going to find alpha 1, Y2 of A, and I'll do it here. So that's our Y2 of A. Our Y2 of A is what? Y2 of A at A is equal to 0. What am I going to have? Y2 of A should be exponential x. When I take the partial differential, I'm going to have this. Our Y2 of A, this is our prime. Y2 of A is exponential x. When I take the power, I differentiate. Alpha 1 Y2 of A, I'm going to have exponential 1 Y2 of A. If I have exponential 1 Y2 of A, it means what's our alpha 1? Our alpha 1 is 1. So Y2 of A, that is, this is exponential x. Then when my x is what? A, what is my A? A is 0. If my A is 0, it means 1. So my Y2 of A is what? 1. That's what it means there. Then beta 1, Y prime of 2, I've done it. There's Y prime of 2 is this. Y prime of 2 of B minus 3 expression minus 3. So I will now plug all these things into this. So my final answer will be, when my A is 0, I'm going to have 1. Then when my A is 1, it means I'm going to have exponential x, exponential. If my A is 1, what is my A? My A is 0. If I put exponential 0, I'm going to have 1. I've done that already. Then if I have 1 here, I'm going to have minus 3 as well. Minus 3 exponential minus 3. So it means if I substitute all these things according to their constant here, I'm going to have 1 1 minus 3 exponential minus 3e. That is my determinant will be this. It means if I solve this, all this will give me 1. All this will give me minus 3 exponential minus 3. All this will give me 1. Then alpha 2 Y2 of B plus this is going to give me E. So, and I've write the real constant of this, the constant of all this alpha and beta. I've written it outside. So we just plug in all these things according to what is here. So it means if you take the determinant of this is a square matrix. When we multiply this, and I'm going to have E, then minus 1 multiplied by this, I'm going to have minus 3 exponential minus 3. So if I solve this, I'm going to have E plus 3 exponential minus 3. You can see that our determinant is not equal to 0. That is our determinant. That is E plus 3 exponential minus 3 is not equal to 0. So the reason why we are considering the theorem is that we want to look for is it y of s, that is it the only general solution of homogeneous problem? Is it the only one that gives us trivial solution? So that's why that is we now test it for determinants. You can see that our determinant is not equal to 0. So it means the general solution to this boundary value condition, it is at when it's equal to 0 as well. The only solution of this boundary condition of a trivial solution is what? Y of s is equal to 0. It means this is how to solve a boundary value problem. A boundary value problem. So it means our only solution of this boundary condition, that is what? Y of s is equal to 0. That is a trivial solution. Our determinant is not equal to 0. So the solution of y of x, the solution that gives us the trivial solution is only when when y of x is equal, that is, the only solution is y of x is equal to 0. Our determinant is not equal to 0. So I hope you find it interesting. Don't forget to share and click on the notification bell. You'll be notified when I upload a new video. Thanks for watching.